Now, I know I touched a little bit upon decimals in the place value video that I did for the previous topic. However, it's important that we revisit this as we start going into decimals a little bit deeper and understanding the place values a little bit more. So this came from the previous video where we looked at place value of whole numbers, and we said the units are sort of like our ones, our tens are sort of like this, our hundreds are sort of like this, and each digit of a number can be broken up into units, tens, hundreds, so on and so forth of whole numbers. But we kind of extended upon this and said that, well, the same thing occurs with decimals, except kind of in reverse. So our units are sort of here, our tens, our hundreds, and then our thousands. But when we go the other way, we start with tenths, all right? And that's sort of breaking a whole number into 10 smaller little segments. But fraction-wise, we refer to these as 1/10ths. These are 1/100ths. These are our 1/1000ths. And these are our 1/10,000ths. Okay, and we can represent numbers in these sorts of forms. So for example, and we did touch upon this in that previous one, we looked at how do we represent numbers in expanded notation. Well, we've got the number 36.5 here, all right? And what this means is we've got 3 of our tens, okay? 3 of our tens, or 3 times 10. We've got 6 of our units, so we're adding 6 of our ones, all right? And we've got 5 of our tenths, so we're adding 5 of our tenths. Okay, and what we've now got here is a sum of its parts, essentially. So we can kind of simplify this if we wanted to. I'm going to simplify at least the fraction part of it. So we've got 3 times 10 or 30 plus 6 times 1, which is 6. Or maybe I will simplify the whole lot. So let's go 30 plus 6 plus 5/10. All right. So that way we've kind of broken up into the sum of its parts. Now we can apply that with other values as well. So let's just erase what we've got here. And go, we've got this 3 units and then 0, 2. So we've got 2 hundredths here. All right. So what we've now got is the sum of its parts is 3 by 1s because they are units. We've got 0 tenths, but we've got 2 hundredths. All right. So 2 by 1 over 100. 3 units is going to be 3. 2 times 100th is going to be 2 hundredths, like this. Okay, and that, once again, is a sum of its parts. Let's do one more just to get our head sort of around what we're doing here and just, revise what was in that previous section. So we've got 100.53. So the total sum of its parts, and I'm actually going to break this up in 2 different ways here. The one that would answer this question correctly first, which would be we've got 1 of our hundreds, so 1 times 100. We don't have any tens, we don't have any units, but we do have 5 tenths, so 5 by our tenths. And we do have 3 of our hundreds, all right, so 3 times 100. Now simplifying this, 1 times 100 is 100. 5 times tenths is 5 tenths. Then 3 times 1/100th is 3 100ths. Okay. However, we could have thought about this decimal part of it as, obviously we've got the 1 by 100, but we could have thought of it as being 53 hundredths. And this is just an important note for later as we start working through this topic, is we can actually think of this as a group, but it'll always be of that last value digit. Okay, so this is 53 hundredths, and we can think of it like that. All right, so we could break it up into, it's not quite its sum of it, all of its parts, but at least it's part of it. So I just kind of want to highlight that as something that is useful for later on. However, I want to continue this thought of expanding the following or writing the following in expanded notation. Okay, so when we've got something that doesn't have a whole number, all right, we don't have this section anymore. What we do have is this 5, 4, 6, and 8. Okay, now we can think of this here as how many 10,000ths we have. I just want to expand upon that sort of notion. So we can think of this as being 5,468 10,000ths. All right, that is an equivalent of it. All right, and this is really useful when we start trying to represent them back as fractions later on. However, it wants us as expanded notation. So what this actually wants us to do here with this problem is break it up into its tenths, its hundredths, its thousandths, and its 10,000ths. So this equivalent is we've got 5 lots of our tenths. We've got 4 lots of our hundredths. We've got 6 lots of our thousandths. And we've got 8 lots of our 10,000ths. And we can multiply these out just to simplify them to make it the sum of its parts. So we've got 5 tenths plus 4 100ths plus 6 1,000ths plus 8 10,000ths. Now we could simplify these fractions. I won't here for the moment, just for the purpose of expand notation. But that's how we represent it as a sum of its parts. Now I will do just one more just so we've just got our clear head around it for this sort of these types of questions it's asking me at the moment. So we've got 3 wholes and 38 hundredths. That's how we'd actually read that. So 3 wholes and 38 hundredths, which is going to be 3 of our ones plus 3 of our tenths plus 8 of our hundredths. 3 of our ones is 3, 3 of our tenths is 3 tenths, and 8 of our hundredths is 8 100ths. Once again, we've now got an expanded notation in the sum of its parts. Now, one last thing is how do we get a fraction back into decimal form? And this is the whole reason why I'm showing you things like this, because this is the easiest way to represent a fraction back straight into its general form. So let's look at this. Okay, we have 65 1,000ths. We go, well, the 1,000ths isn't here. It isn't here. It's here. So we need to write the 65 starting with the 5 here on the thousandth column. Okay, because this is 5 thousandths. So we put the 5 here, we put the 6 here, all right, and we put zeros everywhere else because we don't have a whole number here. Okay, and what we've actually got is the decimal straight away. It's 0.065, which gives us our 65 thousandths. And if we can think of numbers like this when we look at this decimal place as 65 thousandths, it makes going the reverse so much easier to do. Okay, so let's have a look at what happens when we've got a mixed fraction. Well, with a mixed fraction, we just deal with the whole number separately. So the whole number is 4. That's 4 units. So we put our 4 in here. And then we look at the next one, which is 32 hundredths. Our hundredths column is here. So that's where the 2 needs to go. And then the 3 goes into here. So we've got the 32 hundredths. And suddenly we've got our decimal of 4.32. Or if you want to read it properly, it's 4 32 hundredths. And this is the reason why I think it's really, really useful to start getting used to calling decimals to what they actually represent. Don't go 4.32. It's a habit that everyone gets into. Think of it as 32 hundredths. Because when you start seeing this, you'll make sense of its decimal equivalent a lot faster.